In 2000, a new facility with spectacular architecture opened in Hanover in northern Germany, a research institute and clinic specialising in neurosurgery. The exterior shape of the 38-metre-tall, 9-storey building was modelled on a human brain. The founder and director of the institution, Professor Samii, recalls,
"We thus created, for the first time in the history of architecture and medicine, a building in the shape of a brain and equipped it with the most advanced technology, the International Neuroscience Institute, in short INI."
There is now another institution following this model and in the same architectural design, in Beijing, in cooperation with the Capital Medical University. The third and largest facility is finally the new Iran INI. This is about 4 times as large as the Hanover facility, with around 500 beds over 54,000 square metres. The main building is also designed in the shape of a brain. In addition to 14 ultra-modern operating rooms and lecture halls for students, something special is in the making here. A new museum is to be built in Tehran as part of the Iran International Neuroscience Institute and on the initiative of its president, Professor Samii. It will be dedicated to neuroscience in general, as well as the life work of Professor Samii in particular. He says,
"This museum will be a novelty both in the medical world and the museum world. It will present our current knowledge of the human brain to everyone who is interested in medicine and the human body. It will appeal to a general audience and to scientifically trained visitors in equal measure. We are developing this new museum with an international team of museum experts, scientists and designers, another example of interdisciplinary cooperation. We offer all our partners in development and implementation a unique and innovative platform. And I hope that future visitors will take the inspiration that they will gain from this museum to the rest of the world. Networking knowledge is essential for driving research."
The museum will receive visitors in a spacious foyer with an information counter. Visitors will also find a cafe and a museum shop in the welcome area of the museum. In the foyer, visitors will receive an overview of the history of the INI at its locations in Hanover, Beijing and Tehran, using models, photos and graphics. Professor Samii will greet the visitors with an introductory film in which he will briefly explain the organisation of the museum's content. Following this greeting, the visitor is to take part in a question and answer game to pique his or her interest in the overall subject. The questions and answers are attached to rotatable golden pillars that structure the floor space and content and provide a playful introduction. In this way, the visitor is introduced to the exhibition ahead, which she or he accesses by taking the elevator all the way up to level 5. The narrative is kicked off by a big exhibition wall on level 5, with facts and figures about the brain and nervous system. Here, the visitor is provided with an introduction to the basics of neurology. In this way, the museum can become a medium for the public understanding of science. On the back of this richly detailed exhibition wall, there is a film cabinet that is equipped for 3D projection. The footage could be visualizations of the latest imaging techniques, 3D pictures of the brain and nervous system, microscope images, or pictures of surgical operations. A central element of the exhibition is a chronological presentation of the historical development of neurosurgery. There are glass steles on the inside of the ramp facing towards the atrium. They tell the history of neurosurgery in the form of chronological information, images and objects. Selected topics in the historical development of the neurosciences, and in particular neurosurgery, are to be presented in more depth in spacious display cabinets. Professor Samii announces,
"The museum will provide, in particular, an original and comprehensive overview of the history of neurosurgery, to which I myself have been able to contribute over 5 decades. Finally, the current practices of imaging and microsurgery, nerve grafting and skull base surgery are explored, as is the future field of neurobionics."
Level 4 is dedicated to the senses. The exhibition architecture and the exhibits lead the visitor into a world of sensual experience and sensory delusion. The relationship between environment and perception becomes clear, for example, when an installation made of light and artificial fog prevents proper vision. The visitor's ability to see, smell, taste, touch and hear is put to the test. Enlarged models will show how the sensory organs work and how they react to stimulation. Narrow passageways challenge the sense of touch, and a cabinet of scents can be explored by the nose. Level 3 is dedicated to the central and peripheral nervous system in humans. It shows that the central nervous system monitors all of the body's movements. The sensory organs supply the information necessary to make this happen. A larger-than-life interactive room sculpture symbolizes these interactions. The vegetative nervous system controls many vital bodily functions, such as breathing, digestion, and metabolism. Level 2 opens up the chapter about our mental faculties. Thinking, speaking, feeling, and remembering are activities that are characteristic of the human individual. It is our conscious self that writes, makes music, creates art, does science, and forms society. This section of the exhibition presents the wonders of human consciousness. The question as to whether the phenomenon consciousness will ever be fully understood in neurobiological terms remains unanswered. Level 1 looks at the relationship between brain and computer. This spans a wide field of interest that ranges from research on artificial intelligence to the neurosurgical wiring of nerve cells with computer chips. The visitor can stand within the image of a server farm that symbolizes the power of databases and networks, and a contrast to this is provided by a large hologram of the human head. Will computer technology ever be able to replicate the complexity of the human brain? More likely than this is a symbiosis between humans and technology, with an increasing number of new interfaces. Professor Samii sums up the guided tour through the museum.
Museum visitors will learn here about the basics of neuroscience within the immediate vicinity of the IINI institutions and their innovative neuroscience research. The exhibitions will offer something for all our senses and will be curated with the flair of a modern science and cultural history museum. I want to do everything in my power to pass on to the rest of the world as fast as possible the knowledge we have gained about the clinical neurosciences so that all human beings can be diagnosed and treated with the same quality.